Today we're going to be starting everyone's favorite topic of money. So today we're going to be talking about annuity. So looking at this first question, suppose Hiroshi deposits $1,000 at the end of each year for 5 years. His account earns at 6% per year compounded annually. How much has Hiroshi saved at the end of 5 years? So what we want to do here is determine the balance in the account at the end of each year, and we're going to be putting it in the table. So some important information here. Depositing $1,000 at the end of each year, going on for 5 years, and it's 6% that's compounded annually, meaning compounded yearly. So starting off, it shows at the end, for year 1, starting balance is 0. At the end of the year, there's $1,000 deposited. Since it's at the end of the year, there's no interest earned on that. So that end balance is $1,000, which carries into year 2. Year 2, there's $1,000, and we're earning 6% on that. So 6% of 1,000 is $60. And then another $1,000 is deposited at the end of year 2. So if we add together the 1,000, the 60, and another 1,000, we have $2,060 at the end of year 2. So that's what we're carrying into year 3. So we want to find 6% of the 2,060. We can do this by changing the 6% to a decimal. So 6 divided by 100 will be 0.06. And we multiply that by the starting balance of 2,060. So we get an interest that's earned in year 3 of $123.60. And again, end of year, $1,000 is deposited. So we're going to add these 3 numbers together. We get $3,183.60. Which is going to be our starting balance for year 4. That number is multiplied by 0.06. So we get $191.02 interest earned. Another $1,000 is deposited into the account. Adding those 3 numbers, we get $4,374.62. Carry that amount into year 5. That gets multiplied by 0.06. And we get $262.48. And again, another $1,000 is deposited. Adding those 3 numbers together, we get $5,638.09. So in 5 years, Hiroshi has saved $5,638.09. Okay, so the amount of an annuity or future value. An annuity is a series of equal payments made at regular intervals. The amount of an annuity or future value is the sum of the payments plus any interest accumulated. We will consider only ordinary simple annuities where payments are made at the end of each period. Situations involving annuities, saving for education, saving for retirement, saving for a large purchase, and so on. Okay, so as we go through this lesson, a lot of it should be review from last year, but if not, we are going to take it slow, step by step, and if there's any questions, please let me know. So when we're talking about compounding periods, that first question said annually, meaning once a year. There's more calculations to do when it's not annually. So if it's broken to semi-annually, quarterly, monthly, bi-weekly, weekly, or daily, these are our other options here. Our number of times is in the chart here. So semi-annually means twice a year. Quarterly means 4 times. Monthly is 12. Bi-weekly is 26. Weekly is 52. And daily is 365. Okay, so these are amounts that you should know. If you're not sure of that, then you'll have to, as you work through it, then you'll start to remember what each of these terms means. Okay, so suppose $450 is deposited at the end of each quarter for 1.5 years in an investment account that earns 10% per year compounded quarterly. What is the amount of the annuity and how much interest does the annuity earn? So the interest rate we are looking at, it tells us we have 10%. We want to make that into a decimal, so we divide by 100. That gives us 0.1. And it also tells us that this interest is compounded quarterly, so this 0.1 needs to then be divided by 4. Quarterly means 4. So we get 0.025 as our interest rate. And if we think about our number of quarters, here we're being asked for 1.5 years. So for 1 full year, that's 4 quarters. And then if we have another half of a year, that's another 2 quarters. Or we can do 1.5 times 4, and that gives us the same answer of 6. So there's 6 quarters. Okay, so with our chart here, we're going to have 6 quarters that we are calculating for. Okay. So again, we are having money deposited at the end of each quarter, meaning our starting balance is 0. When we have $0, we can't earn any interest on that. so that's going to be 0. And then there's $450 deposited. So at the end of the first quarter, we have $450, which is brought into the start of the second quarter. Now the balance of $450, we're going to multiply that by our interest rate of 0.025. And we get $11.25 as the interest earned on that money. And another $450 is going to be deposited. So adding those three numbers together, 450 plus 1125 plus 450 gives us 91125. That's our starting balance for quarter 3. And that number is getting multiplied by 0.025. That's our interest. And our interest here is going to be 22.78. And again, end of the quarter, another 450 is deposited. Adding those three numbers together, our ending balance for quarter 3 is $1,384.03, which is then our starting balance for quarter 4. Multiplying by our interest rate, we get $34.60, and another $450 is deposited. Adding those together, we get $1,868.63. And in quarter 5, we're multiplying that by our interest and gaining $42.72 and depositing another $450. Adding those three numbers together, we get $2,365.35, which is the starting for quarter 6, our final quarter here. Multiply that by our interest rate, 0.025. We get an interest of 59.13 and our last deposit of $450. And our ending balance at the end of 6 quarters is $2,874.48. So our amount of annuity is the $2,874.48. So that's the future value on our investment. Okay, the other question we're being asked is how much interest does the annuity earn? So looking at just the column for interest, we can add all of these numbers together to figure out the total amount of interest that was earned. So adding 11.25, 22.78, 34.6, 42.72, and 59.13. If we add all of these, we get a total interest of 174.48. Okay, so this is using a chart. The quicker way to do this is actually using a formula, not having to go quarter by quarter. So with using our formula is A equals R times 1 plus I to the exponent n minus 1 over I. So our A is the amount in dollars, that's our future value. Our R is the regular payments. I is the interest rate per period as a decimal. And N is the number of compounding periods. So in order to calculate some of these, our regular payment, that's going to just be what we're told in the question. But when it comes to our I and our N, so our interest rate and our number of compounding periods, we're going to have to do some calculations. So your interest rate, you're going to be given as a percent. We change that to a decimal by dividing by 100. And from there, we still need to divide that by the number of compounding periods that there are. And that will be our value for I. And when it comes to our value for N, our number of compounding periods, we're going to take our number of years that we have and multiply it by the number of compounding periods. Okay, so that's how we have those values. So if we were to take the same question that we already made a chart for, and instead here we are going to use the formula. So our R is our regular payments, how much we're going to deposit each time. So our R is $450. Our interest, I, we have the 10%, which we want to divide by 100. We get 0.1. And then we're dividing by our number of compounding periods. Since it's quarterly, we divide by 4. Okay, so the same interest that we had already calculated, 0.025. And again, our same N, our same number of compounding periods. This goes for 1.5 years. And we multiply that by our number of compounding periods. Since it's quarterly, it's times 4. So our N is 6. So we need to plug all of these values into the equation. So A is equal to 450 times, and we have 1 plus 0.025 to the exponent 6 minus 1, and that's divided by 0.025. Okay, so all of this can be put in your calculator. You don't necessarily need to write out all the steps, but you are more than welcome to. But in my calculator, I'm going to do brackets first, so the 1 plus 0.025, so 1.025, and that's going to be to the exponent 6. From that, we subtract 1, and we're going to get 0.1596, this decimal continues, times 450, and divide that by 0.025. And we will get $2,874.48. which matches the chart that we did a couple of slides ago. Just not having to do the calculation for every single quarter. We can jump right to the answer here. Okay, so looking at another example, Dana invests $60 each week for 25 years into an RRSP account that earns 6% per year compounded weekly. How much will Dana have after 25 years? So we see that Dana is investing $60 each week. So our regular payment is $60. Looking at our interest rate, we have 6% compounded weekly. So our 6%, we want to change that to decimal, so it's 6 divided by 100. And we also need to divide by our number of compounding periods. There's 52 weeks in a year, so we need to divide by 52 as well. So 6 divided by 100 divided by 52 gives us 0.0011538. Okay, a big decimal there. 0.0011538. 5. And our number of compounding periods, this is for 25 years. So the 25 years times the number of compounding periods, which is weekly, so 52. And 25 times 52 gives us 1,300. So we can put these values into the equation. 60 times 1 plus 0.00115385 to the exponent 1,300 minus 1 and divided by 0.00115385. Make sure that's legible. Okay. From there, we can put it in our calculator. Okay, so you don't necessarily need to keep all the decimal points, but just keep in mind, the more decimal points that you keep, the more accurate your answer will be. But as long as I see your steps, you're following everything correctly, then I will be happy. So the first thing is 1 plus that long decimal there. And that's going to be to the exponent 1,300. And we subtract 1, times that by 60, and divide it by the decimal 0.00115385. Okay, so we're going to get $180,846.96. Okay. So before we figured out our interest by just adding them all up in the chart, here we don't have that. So the way we're going to calculate this is we're going to have our future value, our total amount, the 180,846.96. From that, we're going to subtract the amount that Dana has invested. So that's going to be the $60 a week, and the number of payments that are being made is the $1,300. So we're going to subtract the $1,300 times 60 because that's the amount that has been invested. Okay, so multiplying the 1,300 by 60 first, and then that gets subtracted from our total amount. We get $102,846.96 in interest. Okay, so that's using our formula. Now, the last piece we have is using a TVM solver. So we are calculating all of these values the same. It's just we're going to then put it in a specific calculator that will calculate it for us. So on this calculator, our N value is our total number of payments. That's still going to be our number of years times the compounding periods. Okay. Our interest rate, we're keeping this as a percent. We don't need to do anything with this number. So with our formula, normally we need to calculate I. This is just using the percent that we're given in the question. Okay, our present value is the amount we're starting with. All the questions that we've seen so far, we're starting with $0. Our regular payment amount, that's the amount that's being put in at the end of every compounding period. And when we put this into our solver, we need to put it as a negative number for it to work. Okay, so just keep that in mind. Our future value is how much we're going to have at the end. Our payment periods per year and our compounding periods per year, these are the same. So we're just putting the amount. So annually, we would put 1 for both of these. If it was semi-annually, we'd put 2. Monthly 12, quarterly 4, so on and so forth, with all of our different compounding periods that we could have. So those bottom two are the same number depending on the number of compounding periods in a year. Okay, so looking at this question here, we're going to figure out all the values that need to go in the TVM solver, and then I'm going to flip over to that link so that we can answer the question. So after finishing college, Edward decides to start saving for a down payment on a house. At the end of every month, he deposits $400 into his savings account that earns 6.5% per annum, compounded monthly. Determine the amount in Edward's account after 5 years of saving. Okay, so what this tells us is that our the regular payments that are being made is the $400. Our interest is 6.5, compounded monthly, so that's compounded. The compounded number here is 12, and it's going to be after 5 years. So our number of compounding periods is going to be the monthly number 12 times our number of years, which is 5. So our N value is going to be 60. Our interest rate, remember, we don't have to do anything with for the TVM solver, so we just put 6.5. Our present value is how much he's starting with at the very beginning, meaning he's starting with $0. So that's going to be 0. The payment amounts is the $400. Remember, for this value, it needs to be a negative, so we're going to put negative 400. The future value is what we want to find, so that's going to be left blank. That's what we're going to hit solve for. And our payments per year and our compounding periods per year, these are monthly, so these are both the number 12. So flipping over to the TVM solver, you guys will have this link on Google Classroom, and this is what it looks like here. So what we do is put in all the values that we have calculated. I'm doing that now. Okay, so once we have all those values in there, we are going to hit solve for future value. And we get $28,269.50. Okay, so that's the number that I already had written down for future value here. That's what was calculated. And we hit solve for that. Okay, and one more example using the TVM solver. Determine the monthly payments required to accumulate a future value of $10,000 in 4 years. If the payments earn 6.5% interest per year, compounded monthly. Okay, so we're kind of working backwards with this one. We actually want to find out what the monthly payments are, given what our future value is. So here we have the future value being the $10,000, so that's going to go here. This is for 4 years, compounded monthly. So monthly is 12 times 4 years. That's giving us compounding. The number of compounding periods is 48. Our interest, we keep the percent, and that is 6.5. Our present value is the amount we're starting with, which is 0. And our payments and our compounding periods per year, monthly, so we say 12 again here. So we are going to solve for our monthly payments given these numbers here. Okay, so starting over, our N is 48. Our I is 6.5. Our present value is 0. We're solving for our payments. Our future value is $10,000. Our payments per year is 12, and so is our compounding periods. Okay, so we want to solve for PMT, and our monthly payments are going to be $182.98. Okay, so therefore the monthly payments are $182.98. Okay, so keeping in mind that we can solve this through a table, a formula, or using the TVM solver, Complete these questions here, and if you have any questions, please let me know.